segmentation module is a pixel-level defect detection tool that can separate images into different regions, accurately identifying defects and extracting their height, width, area, category, and other information. This info can help you spot defects by filtering data to differentiate between what's a defect and what's not. The segmentation module is excellent at detecting tiny defects in complex scenarios with low contrast, such as scratches, dents or pinholes, and can detect defects as small as 3 by 3 pixels. It's often used to detect defects with irregular shapes and high precision requirements. In this video, we'll set up an inspection to locate any foreign particles on the EV battery pouches. The images in this project are already sorted into OK and NG images using the image tag function. We've also created a region of interest to reduce the image size and improve the performance of the inspection. The position and orientation of the battery pouches isn't consistent, so we need to account for that. The first thing we do is use the NG image tag to filter for images with defects. The filter will then be applied automatically to the image list, and the first defect image will be displayed. So, the first thing we do is create the label. Then we can look for the foreign particle in the current image. There's only one type of defect here, so we can just use the default label option. Every annotation will automatically be a particle defect. We can use the standard circle pen tool to mark the defect. Once we're happy with the annotation, we can save it with the icon in the top right or the S key on the keyboard. When marking defects, it's important to be consistent. For defects with blurred edges, focus on the clearest edge you can see. Don't base your annotations on the physical object. They should be based on the image. Now, it's time to change the filter on the image list to OK. We can then select some of these images and label them as OK. To select multiple images easily, we can hold down the Control key and click on the images we want to include. The selection should cover all product orientations and lighting conditions. When we're done, we can right-click on one of the images and select Set as OK. The next thing we need to do is assign the annotated images to the training and validation sets. We can use the training helper for this task. You'll find this tool in the training and validation section. Then we look at the training parameters. The color space must match the images. There is a mono and color option. These 3 parameters are the starting point for training the AI model. We keep them at default for now. The next parameters are key for getting accurate results from the model. The algorithm works best if it splits the images into smaller sections, and the default setting is automatic image splitting. Our images are around 3000 by 2500 pixels. The algorithm will split the image based on the shorter side, creating sections whose default size is 256 pixels. When we choose the manual setting for the split method, we can choose our own resolution level. We set it to level 10. This will be sufficient for these images. The following parameters control the geometric augmentation during model training. For example, mirrored or rotated images are simulated. As the position and size of the battery pouches vary, we also activate shift and scale. The individual parameters remain at their default values. As you hover over the eye, a brief example of the augmentation is shown. Image augmentation lets the training algorithm make changes to the image, like adjusting the brightness or contrast, or adding noise. We'll leave them at the default setting and get the training started. Once training's wrapped up, we can take a look at the results. The confusion matrix in the evaluation section gives us a quick overview. We can filter the images according to the individual evaluation result by clicking on the entries. We can check that all the images marked as OK are being predicted as OK images, and that all the NG images are being predicted as NG images. You'll find the images of the training set marked in the image list with a green triangle. The validation set is indicated with a red triangle. Images without any marking are not annotated. In this example, we've got 2 OK images that have been predicted as NG. The reason is that we're detecting tiny particles that are within specified limits. To check the defect properties, just hover over the annotation with the View tool. We can use a filter to categorize these images as OK. One simple way to do this is to filter by defect size. The filter is in the Train and Validate section. Pick the validation parameter setting and scroll down to characteristics threshold. We set the minimum defect size for the area at 35. Once everything's set up, just click Validate at the top to check how the new filter is working. In the confusion matrix, all the OK images are now predicted as OK, as they should be. In the real world, we'd take out the 2 OK images from the training set, add 2 more OK images and train again. This way, we can be sure we're getting the best possible performance. One of the images we didn't annotate is flagged as NG. When we take a closer look, we can see a tiny particle in the image. With one click on the dual arrow symbol, we can convert the validation result to an annotation. Another preset filter in the image list is over-inspection. Images marked with this label have more predicted defects than annotations. In the example, we found a particle that we hadn't annotated beforehand in either of the 2 images. The next common filter is called missed inspection. As you can see, the particles we marked individually are now predicted as one defect. We can either accept this behavior or we might need to refine the algorithm. Let's quickly run through this. In the segment module, we should choose representative defects and accurately annotate them as close to their edges as possible. The segment module is great at detecting tiny, low-contrast defects like scratches and pinholes. It's the most important and most used module. It can extract information like defect category and contour dimensions.